The district's efforts to become energy neutral and recover valuable resources using innovative technologies are important to our communities and the future of the Chicago region. Throughout its 127-year history, the district has embraced innovative technologies to treat wastewater and manage stormwater. The district is on a quest to become energy neutral by 2023 and has instituted a variety of creative means to reach that goal. The district's evolution into a resource recovery agency is good news for the public, not only locally, but will have positive ramifications throughout the country. These efforts will reduce greenhouse gases, promote a cleaner and more sustainable environment, and provide a return on investment that will benefit taxpayers.
Welcome to Chicago's Water Reclamation District. We're here on the waterfront, the brand new riverfront. This is a channel that the district 127 years ago reversed to protect the drinking water in Chicago. And the district has been on the cutting edge of innovation ever since. We have a vision statement in our business plan, Recovering Resources, Transforming Water. It's an exciting time to be a part of the utilities as we look for ways to find resource products out of what we used to consider waste. So we are looking to recover water, nutrients, biosolids, and energy. And in this world, we're going to have to learn how to use these things more than once. The future is bright, and we're excited about the things that we're doing.
The MWRD treats and discharges over 1 billion gallons of water per day on average, and the treated water can be used for a lot of purposes. Though it's not quite drinking water, it can be used in place of drinking water for processes such as industrial cooling, cleaning, and irrigation. Use of the clean water at our facilities saves a considerable amount of energy and money and reduces the demand for drinking water. Here at the Stickney plant, we use about 6 million gallons per day for our internal purposes.
We're here at the Solids Management Facility, one of many we have at the Water Reclamation District. Here we receive the organic matter, which is the residual from the wastewater treatment process. That organic matter, called biosolids, comes to these facilities and we further process it into a premium compost product or air-dried product to be used on baseball fields, golf courses, all different types of end uses.
We are not only harvesting nutrients, we are harvesting organic matter which soils need in order to function properly. Soil is an ecosystem. In order for the ecosystem to operate properly, it needs nutrients and organic matter, and biosolids supply that.
Biosolids provide an array of nutrients, including macro and micronutrients like calcium and iron, which turf grass is able to absorb and helps make it more resistant to foot traffic. For a park like Maggie Daly, where there's lots of kids playing and other pedestrians, it's important for the turf grass to be resistant to that impact.
We're at the Calumet Water Reclamation Plant anaerobic digester complex. The digesters take in the organic material that is removed from the treatment process and break it down into smaller, simpler components, very much like our stomachs break down food. We have capacity in our digesters here to take on more organic material that are waste from places like dairies or breweries, ethanol production plants, food plants, places where they have wastewater that contains organic material. We can increase the feeding capacity from the current feed rate of about 800,000 gallons a day, adding another 100,000 to 200,000 gallons a day, increasing our digester gas production up to about 1,700 cubic feet a day, about a 60% increase. That's enough natural gas to heat about 900 homes. Or, because it's going to be turned into vehicle fuel, that's enough compressed natural gas that's the equivalent of about 11,000 gallons of gasoline per day. So that's roughly enough to power 20 cars for an entire year.
We are currently in our phosphorus recovery facility, the world's largest of this type. The district had realized that phosphorus is a non-renewable resource out there that is slowly dwindling within the global economy. Currently, most of it is mined as phosphate rock out of Morocco. Next 20 or so years, that commodity will no longer be there, and without phosphorus, we don't have life. By removing this phosphorus, not only do we remove it from our effluent, which is going to our receiving streams, by doing that, we improve the quality of the receiving streams. So in addition to that, we'll be recovering a fertilizer type product that'll be able to be utilized in place of regular fertilizer.
It could be used in nurseries. It has a good potential as a slow release fertilizer. So like another source of phosphorus or nutrient contamination to the rivers and waterways is from runoff. The benefit of a slow release product is it's not releasing phosphorus unnecessarily. It's releasing only as the plants are drawing it up. So it's being put to the right use.
I'm at the greenhouse research facility at the O'Brien Water Reclamation Plant, where we're doing research on using algae to uptake nutrients from wastewater. This is a technology called Revolving Algae Biofilm Reactor. It was designed by two scientists at Iowa State University. It was originally designed for agriculture applications, and we are applying it here in a unique application for wastewater treatment. The wastewater contains nutrients, nitrogen, phosphorus, which algae needs to grow. The concept using algae for removing nutrients is that the algae can then be reused in some manner, turned into usable products like fertilizer or bioplastics, fish food, bioacids, industrial dyes. So we are putting algae to work for us to recover the phosphorus, to put it back into the economy, back into the cycle, and create useful products.
It's important here at the district to be a steward for our environment. So one of the ways we're doing that here at the Egan plant is by reducing the nitrogen going to the receiving stream. Nitrogen, along with phosphorus, are considered pollutants in our waterways, and this process gets us well on our way of reducing nitrogen that's leaving the plant and entering the receiving stream. It's important to aquatic life, our fishes, plants that naturally thrive in our waterways. So the Nitamox process here at the Egan plant that helps us remove nitrogen from our effluent in the most efficient way possible result in a cost savings of approximately $750,000 a year. And that cost savings comes from reduced energy use. Reduced energy use in the form of less electricity to power our blowers to provide air to the system for treatment technology.
We're at the O'Brien Water Reclamation Plant, where we are doing a research project on a new technology called membrane aerated bioreactor in collaboration with GE Process Water Technologies, who've developed a product they call Z-Lung. The benefit of this technology is that it takes up less space and does more work, and in the process uses less energy than conventional activated sludge. In fact, the oxygen transfer efficiency is so much greater than the conventional aerated bubble reactor, because the oxygen is oozing through the membrane, that the process is about 3 times more energy efficient than a conventional activated sludge system. At a full-scale application, because of the lower aeration requirements, we can actually save on the order of 11 million kilowatt hours per year, which is about $700,000 per year in electricity costs. What happens is you are able to accomplish more treatment in a smaller footprint.
We are here on the Kiri Water Reclamation Plant, which we're using the constant temperature of our sewer system to reduce the cost of the heating and cooling by approximately 40% in the administration portion of that plant. Every home has the AC system in it. When you're looking at your bill in the summer, you notice how high it is, how much you have to pay in the summer, and that mostly is related always to the condensing unit. Instead of the condensing unit outside with the noisy fan, which you guys hear every day, we have, in our case, we're using effluent water to cool the refrigerant down, and in the summer, or heat refrigerant up in the winter. We were using the free effluent water, always under constant temperature, for our benefits.
Here at the Lockport Powerhouse, we've been generating clean hydroelectric power since 1907. The Lockport Powerhouse is located about 35-40 miles from downtown Chicago. It's at the end of what we know as the Chicago and Sanitary Ship Canal. The building itself, the powerhouse itself, stretches most of the way across the canal because we are also a movable dam. We have gates here that we use for flood control or water diversion. We have 9 gates here that we open periodically during a storm event. The reason why we have the Lockport Powerhouse located where it's at is because there is a 38-foot differential between where the water enters the powerhouse or the turbine chamber versus the discharge side, which is the tail race or the backside of the powerhouse that leads to the Des Plaines River. The renewable energy that we generate here is good for our environment and the economy.
Solar hot water system at Egan used to reduce the energy cost in the amount of $12,000 per year, and we use this energy to heat our water. The whole purpose of the project to bring the green technology to the wastewater treatment plant. The solution is being heated here. That antifreeze solution is being heated here, and that heat is later on goes downstairs and transferred to the other loop which has got the hot water tank. So we are gaining 2 things, one is reducing the carbon emission, plus we are saving some money.
Our efforts to recover resources and transform water are possible because of a wide range of skilled professionals. Our staff is key for the success of new projects, and they are vital to our daily operations, ensuring that our natural resources thrive and the Chicago region is a better place to live. We are improving water quality in area rivers and streams while protecting more than 5 million people from flooding. We are always looking for talented professionals who share our passion for innovation and quality service.
The MWRD is building on a history of innovation. Our efforts to become energy neutral and our evolution into a resource recovery agency will directly benefit residents here in Chicago and Cook County. We at the district hope you find our work as interesting and as exciting as we do.